For 1.2, building more checkerboard borders, we have a few videos for you to watch, 3 to be precise. The first one is how do you solve a multi-step equation? That's this video. Next, you'll do how do you use a table to write an equation. And then the last video, your title, you're going to put here, and you should know what it is. It's on your outline sheet that I gave you in class. Just a reminder, your notes go here in this column, and at the very end, you're going to create your summary. How do you solve a multi-step equation? We're kind of going backwards now because we did an equation with variables on both sides for Tuesday. And now for Thursday, we're going to focus on multi-step equations to solve. Okay, just a reminder, you should pause the video right now, write down all this information, and then resume when you're ready to follow along with me. I want you to notice that in the following examples, the equations contain multiplication, division, and addition. So there's multiple operations in one equation. An equation that contains multiple operations will require multiple steps to solve. And you will create equivalent equations at each and every step. I'll explain what that is through the first example. I will complete 3 examples, and I hope to go through them pretty quickly so this video does not go on too long. I want you to notice that there is several operations happening to this problem, so we're going to have to use several steps to solve it. And each time we do a step, you get an equivalent equation to the original equation. I want to remind you to check your answer at the end of this example, and I won't do that for you. You'll do that on your own. And don't forget that you have the steps listed here that you also need to write down. So you should probably pause the video, write it all down, and then resume when you're ready to follow along. So I'm trying to isolate this variable x, and the first thing I want to get rid of is the 3. The 3 is being divided by the equation. So in order for me to get rid of the 3, I must multiply the 3. Now I have 2x plus 1. 3 and 3 reduced to 1, and they're gone. And then now I have 7 times 3, which is 21. When I say gone, I just mean it's there, but anything times 1 is just 1, so we don't write it at all. And then we'll subtract 1 to both sides. Remember, I'm trying to get that x alone. And now I have 2x equals, this cancels out and becomes 0. And then 21 minus 1 is 20. Next, I'll divide both sides by 2, since 2 is being multiplied to x. And now I have x equals 10. And this is my answer. Now that whole equivalent equation, I'm going to circle all the equivalent equations. This equation is equivalent to this equation, which is also equivalent to this equation. And then it's equivalent to the final answer. So if I said give me an expression or equation equivalent to the first equation, you could have gave me any one of these as your answer, and it would have been correct. That is a little bit of a smarter balance test question that you'll look to in the future. Okay, here's our second example. I want to remind you to check your answer at the end, and we will point out the equivalent equations when we're done solving. So for this one, once again, on one side of the equation, which is the right-hand side, I need to combine like terms first. So I'm going to combine the negative 6x with the 2x. Notice the negative always goes with the expression after the negative. Now I have 4 equals 2x minus 6x is negative 4x plus 5. Remember, when there are different signs, we subtract and keep the sign in the bigger number. Then I'm going to subtract 5 to both sides. Once again, subtract, keep the sign in the bigger number, which is negative 1, which equals negative 4x. And then I'll divide both sides by negative 4. And now x is going to equal 1/4. These two reduce to 1, they go away. I cannot simplify this fraction further, so I leave my answer as a fraction. I just remember that negative divided by negative is positive. Now let's look at for the equivalent equations. This equation is equivalent to this equation, which is also equivalent to this equation here, and it's equivalent to our final answer. Here's our last example for this video. We are going to go ahead and solve this equation. I reminded you last time that if you have parentheses, you need to distribute the number or variable first. So we have a 5 on the outside of parentheses. We're going to distribute that first. And we'll get 5p minus 10 equals negative 15. Then we'll add 10 to both sides. And now I have 5p. The 10's cancel. and I get negative 15 plus 10, different signs. One's negative, one's positive. I subtract both from each other and then keep deciding the bigger number. So since 15 is the biggest and it's negative, that means the final answer will be negative, and 15 minus 10 is 5. Then divide both sides by 5, and P will equal negative 5 divided by positive 5 is negative 1. And here's your final answer. Now I challenge you to come up with the equivalent equations to the original equation. So which ones are equivalent equations to the original equation?